Hi, this video will demonstrate the squeeze theorem. And the squeeze theorem is used to find the limit of a function about which we really don't know anything. But we hope that we can find the limits of a left bound, a minimum, and a right bound. All right. So if I can find the limit of this and the limit of this, well, obviously I've squeezed this function and I can figure out the limit of g of x. Okay? You can read through this. Obviously the limit of the minimum needs to exist, and it needs to be some value L. The limit of the maximum, the right bound, that has to exist, and that has to be the same. And therefore, if the limit of this is, say, 2, and the limit of this is 2, and I've squeezed it, right, then the limit of g of x is 2. Okay? Again, assuming that this inequality, this compound inequality, is true. Again, as always, let's look at some examples. So, if I want to find the limit of this function as x approaches 0, our rule says, well, I'm multiplying, right? So does the limit of x squared exist as we approach 0? Yeah, okay, so that's fine. All right, and that says take the limit of the sine of 1 over x as x approaches 0. And we ask ourselves, does this exist? And hopefully we've seen this enough where we can see, oh, there it is, right? No, the limit of the sine of 1 over x does not exist. Remember, we have this crazy oscillation as we get towards 0, and so I don't really know what's going on here. There's no limit. But look at the graph. I do see that there is a minimum value of the function. It's -1. And there's a maximum value of the function, and that's +1. Okay? So we're starting to squeeze. So, again, this does not exist, so I can't use that rule. I have to have another way to figure this out. All right? So what we're going to do, we're going to say, well, I do know something about the boundaries of that. I know that sine of 1 over x is bound between -1 and 1. All right, we just saw that from the graph. Well, I don't want just this piece. I want x squared times all of this. All right, well, if I multiply everything by x squared, right, so I'll have -x squared. And in the middle, I'll have the function I'm actually trying to find the limit for. All right. You're going to see why I'm going to move this in just a minute. Oh, okay, hold on a minute. Okay. So, well, do we know something about the limit of -x squared as x approaches 0? Well, yeah, I mean, this is a polynomial, and that's going to be equal to 0. That's not a problem. What about the limit of x squared as x approaches 0? In the same case, this is a polynomial, so just plug in 0. 0 squared is 0. All right. So I know the limit here, and I know the limit here. Okay, it's a nice simple one, right? Therefore, the limit as we approach 0 of this crazy function, all right, is also equal to 0. And again, you're not going to be able to see the graph all of the time, but it's important to see that. All right, so this graph here is y equals x squared. This graph here is y equals -x squared. You can see as we approach, oh, sorry, and this is that crazy x squared, sorry, y equals x squared times sine of 1 over over x. So you can see as we approach 0, x squared times sine of 1 over x sort of gets squeezed between x squared and negative x squared. And hence we are squeezing that limit to 0. Okay, let's look at another example. All right. Kind of the same thing. We're gonna see that the cosine, right? If I look at this, the limit as we approach 0 from the left, right? Be very careful about that. As we approach 0 from the left, that limit exists and it's 0, so no problem. The limit as I approach 0 from the left for this, all right, this does not exist. All right, and I don't know if I have that up. Not really. Okay, just give me a minute. Let's just graph it, right? The cosine of 2 divided by x. And let's get that out of there. And again, we can see that the limit doesn't exist. We have that same crazy oscillation, but there is a minimum of -1 to 1. So let's use what we know to figure out our limit of the whole thing. So again, I'd like to use my rule here. This exists, this does not exist. I have to do something else. Okay? So, what do I know? I know that this cosine of 2x squared is bound by -1 and 1. Okay, no problem. Well, I want to multiply everything by x cubed. Right, so that's negative x cubed, that's x cubed, and that's x cubed cosine of 2 over x. Now, you have to be very, 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 very thoughtful about the entire problem. We're approaching 0 from the left, which means we're choosing an x value that's negative. Right? If I'm approaching 0 from the left, right, these numbers are negative. So when I multiply by, when x is negative, x cubed is also negative. Right? Imagine I choose from the left, I choose -1. Right? -1 cubed is -1. So if I'm multiplying by -1, I hope you remember you need to switch the signs. Okay, you need to switch the signs. This is quite important. All right, so you have to, again, really be thoughtful about your algebra. And again, I like it when it's less than, so I'm just going to switch everything. All right, so be very thoughtful when you use the squeeze theorem, because you may be multiplying by a negative number. Okay? But now that I have this is okay. Does the limit of x cubed exist as we approach 0 from the left? Of course it does. It's 0. Does the limit of negative x cubed exist as we approach 0 from the left? And yes, that's 0. Okay, so again, I've squeezed that limit. I've squeezed that function and this is going to be equal to 0. So let's see if we can, where are you? There you are. Okay, let's see if we can see that. Okay, so our blue graph, this is y equals x cubed. Our sort of red graph is y equals negative x cubed. As we are approaching 0 from the left, notice that these two functions squeeze, right? Our green graph is the function that we are interested in finding the limit of. Okay, you can see the limit is 0. All right, so squeeze theorem isn't that bad. The thing is, if your left, let's say for instance your left boundary is negative infinity, well, what do you do with that? You can't really do anything with that. So you can't find the limit using the squeeze theorem. If your maximum is positive infinity, what are you going to multiply it by? Remember, infinity is not a number. I can't multiply 1 times infinity or 2 times infinity. I can't do that. So the squeeze theorem works when we have a minimum and maximum to work with. Okay, let's look at one more example. All right. So you can see here, right, that sine of 1 over x. That's kind of going to give us a clue that we can do something here. All right. So I'm going to start off by saying, okay, the only thing that I know when I put 0 in, obviously this is undefined and that doesn't exist, the limit doesn't exist, so I have a problem. But I do know that this function is bound by -1 and +1. No problem, right? I'm going to use a base of e for everything. All right, so what I'm doing is slowly working my way to get the function that I'm interested in. All right. Again, as soon as I know something about this as x equals 0, well, the limit of this is e to the -1, limit of this is e. I'm squeezing it, but not that much. Okay, let's multiply everybody by x. And when I do that, this middle thing is the function I am interested in. So, here we go. Let's see if we've squeezed properly. All right. The limit of x times e to the -1 as x approaches 0. This exists. The limit exists. It's 0. This limit exists. It's e to the -1. When I multiply that, that's 0. Okay. The limit of the maximum here also exists, and it is 0. Hence, the limit of that function is 0. So there is your squeeze theorem in action with 3 problems. I don't want you to walk away saying, well, it seems that the limit is always 0. It doesn't always have to be 0. It's going to depend on the function you have. Later, either in our course or in a future course, you may see that the squeeze theorem gives you a different limit. Okay? All right. Well, I hope that helps. Thanks for watching. Again, you may want to go back and pause and look at how we're taking something that we know here and sort of building to the function we want. All right? Until we find limits that exist and limits that are equal. All right? Hence, we have to squeeze the limit of that function. Okay, well, I hope that helps. Thanks for watching.